Question number 32. Escape speed from the surface of the earth is v escape. Okay, let us write out what is the formula for v escape. Square root of 2gm divided by r. Okay, radius of the earth is r. The satellite of mass m is in orbit with the radius of height r by 4. So this is your radius r. From a height of r by 4, the satellite is present over here. It's orbiting like this over here. Okay, what is the energy required to move the satellite to infinity? How much energy you need to supply so that it moves to infinity? So this was the question. Definitely from here you need to project this upwards with an escape velocity. Okay, now what we'll do is first find out what is the energy at this point. The energy at this point is nothing but your potential energy plus kinetic energy. Right? Because the satellite has to orbit, it cannot stay there. If it stays there, it will fall down, right? Okay, so only when it orbits, okay, it will be staying over there. Now what do we do here? The potential energy is given by minus gmm. It will take some time. Minus gmm divided by r plus r by 4, because it's not at the distance r, it's at a r by 4 from here. So which should now be equal to minus 5 gmm divided by minus 4, right? 5r by 4, this should be minus 4 gmm divided by 5r. This should be your potential energy. What is your kinetic energy? Kinetic energy is nothing but half mv r by L square. Now what is this? This should be equal to half m into gm divided by, what is the net distance? This should be 5r divided by 4, which should now be equal to 1s are to 2s are. This should be, this 2 goes away, so 2gmm divided by 5r. Okay, which is positive. Potential energy is negative. That's why it has been bound to the earth or the planet. Okay, earth here, right? So therefore, what is the total energy now? Total energy, let me scroll this a little bit upwards. The total energy is equal to 2gmm divided by 5r, kinetic energy, plus potential energy, which is minus 4gmm divided by 5r. So what is the answer? Answer is nothing but minus 2gmm divided by 5r. Okay, total energy is negative. Why negative? Because it's bound. Okay, next, what is the next thing? You need to find out how much energy you need to supply. It has been bounded over here, right? So you need to supply this much amount of energy. If you supply this much amount of energy, it will escape, right? So that, what do you mean by free particle? Free particle is one wherein the total energy is equal to 0. To make this 0, you need to give 2gmm divided by 5r. This should be your answer. But unfortunately, there is no answer related like this. It is in terms of v escape square. What we do is, we know what is v escape, right? V escape, let me write it down separately. Yeah, just taking more than a minute. Okay, so v escape is equal to 2gm divided by r. We already know this, root of, right? So v escape square is equal to 2gm divided by r. Okay, the square goes away. Now I have gmm by r here, right? Okay, what I will do is I will take mv escape square, because I have another m here. So I will write this as 2gmm divided by r. I get this formula. Now what I will do is, see this, I'll plug in here. So total energy, the energy required to make it escape from the earth is nothing but, so 2gm, I'll write 1 by 5, and this 2gmm by r, I'll substitute this as mv escape square. So which should be mv escape square divided by 5. Okay, let us see which one is it. A is the right answer. Okay.